Yes, in the last class, we discussed about uh, a brief introduction of tribology, which is also discussed in our earlier classes. We also discussed what is meant by tribology. So it is an interaction of wear, friction, and lubrication. So friction and wear are the two problems. For that, a solution called lubrication bearing as well as bearing material. Okay. So this process is called as a tribological process. In this tribological process, whatever the solution we got to reduce the friction, to reduce the wear, it is called a tribological solution. By applying this tribological solution, we can achieve we can achieve a better life of the component. Okay, we can increase the life of the component by using proper tribological solution. We can increase the life of the component. Indirectly, if you increase the life of the component, it means that we can also save the lot of money. Correct? If you increase the life of the component means we reduce the operating cost, so that indirectly it saves the lot of money. Means the economical growth of the country or economical growth of the industry is directly depends on the tribological solution. And this already studied in the US and UK. They already gone through this process, and they came to conclude that by applying tribological solution, a proper tribological solution, they can save lot of money in terms of billion. They save the money. So means it is become a more economical. Clear? That's why it is very important to study the tribological process as well as tribological solution. In that way, so this bearing material is also a important concept. Clear? It's an important topic which we discuss. Means tribological solutions called, one is lubrication. Of course, wherever the possible way, we can introduce the lubricant to reduce the friction as well as wear. Friction reduces means indirectly wear also reduces. But in some of the cases or some of the process, we cannot able to introduce the lubricant. In that in in that situation, either we can go with the a bearing itself a one solution. But take an example of fan. So in the fan, we cannot able to apply the lubricant, so we use the bearings. In some of the situations, we cannot able to use the bearing. In that, we have to go with a material which itself having a wear resistant material. Clear? So that is what a bearing materials. Clear? So study of a property of a bearing material, it is also a one important concept. Means in the in which condition we have to use the which type of bearing material. Clear? So in which condition, so which type of bearing material we have to use, and what are the different types of bearing material, and what are its good characteristics of bearing material. Okay? Clear? That is what we are going to discuss in your fifth module called bearing materials. So this bearing material are processed to achieve desirable properties to minimize bearing performance and life. It maximizes the performance as well as a life of the component. That is the first important thing. Why we have to use this bearing material is, first thing is to increase the performance. By using this proper bearing material, it will increase the performance as well as also increase the life of the component. These two are the important parameters. By using proper bearing material, we can increase a bearing performance as well as life of the component. That's why we have to study the bearing materials. Okay. So next, some of the examples of bearing material. So which materials we can use for bearing? Okay. Can we use this wood as a bearing material? It is not possible. Okay. So some of the best example of bearing material are ceramics. Have you heard ceramic bearings? Okay. So one best example is ceramic bearings, chromium steels, alloy steels, stainless steel, plastics, polymers, okay, or composite materials. So these are the best examples of a bearing materials. In the next class, we will briefly discuss a bearing materials. Okay. So these bearing materials are classified hardened materials as well as case hardened materials. Okay. In some of the cases, in ball bearings, we directly used hardened materials. We do not go with the case hardening. Directly, we use some hardened materials for a ball bearing. In some of the situations, we have to go with a case hardened materials. You already know that what is meant by hardening. What is meant by hardening, heat treatment. Okay. So these are all case hardened materials. In some of the materials, we have to use this case hardened materials. That is what rolling bearings. In the roller bearings, we have to use a case hardened materials. In some of the ball bearings, simply we are using hardened materials. Okay. So these are some examples of bearing materials. These are the different types. So these are the different types, and these are the bearings which are made by different materials. So different materials in a different operating conditions need a different properties. Clear? Just like a composite materials. So in the different operating conditions, it need a different properties. If different property means it is having a different material. You already know that what is meant by material. What is meant by material? Material means it is a substance or it is an object used for particular applications. Clear? So here bearing materials means the material which is used for manufacturing of bearings is called bearing materials. Again, this bearing materials is directly depends on the type of the applications, type of the requirements. Clear? You can use gold as a bearing materials. But what happens if you use gold as a bearing materials? Of course, it is having some advantages, some disadvantages. But if you use as a gold as a bearing material, what happens? The cost may become very high. You can use stone, granites, ceramics. Okay, you can use a wood as a bearing material. But what happens? The cost is very low. Wood. Yes, it is having a very low strength and it easily catches the fire. Clear? So these are some advantages as well as disadvantages. Based on the applications, we have to select a proper bearing material for manufacturing of bearings. Clear? So bearing material preferred characteristics means desirable characteristics. Means what are the properties we expect in our bearing materials. So first property means it is based on the load capacity. You just note down. The first property is a load capacity. The load carrying capacity of the bearing is the first important property. A load carrying capacity of the bearing material is the very important and primary property of the bearing material. In that, the allowable compressive strength. The first thing is, first the load carrying capacity. In that, the compressive strength of the material can withstand without any appreciable changes, without any deformation, it withstand the load. And also any changes in the shape. So that is the deciding factor, deciding bearing material. If you go for very high load carrying capacity, in that you have to choose a very high allowable compressive strength of the material. The material of the bearing should be very high compressive strength. Because if you apply the load, if you apply the compressive load, clear? Compressive load is different and tensile load is different. I think you already studied in your mechanics of materials. Okay. So in the compressive means the load which is towards the object. Clear? So if the load increases, what happens? It may deform the shape, it may changes the dimension. But in the bearing material, if any dimension changes, what happens? In our bearing, if any dimension changes or shape changes, it may lead to the direct contact between the two surfaces, it may lead to the friction, then wear, then failure of the component. Clear? So it withstand the very high compressive strength. And similarly, the strength to take care the load as well as speed combination. If the very high rotating means if the it is in we already know that in the bearings, if the speed increases, it also increases the pressure in the lubricant. Okay, if load increases as well as speed increases, so it should sustain the strength, means combination of load as well as speed. It should sustain the combination of speed as well as load. It should have very high strength. Next, fatigue strength. So fatigue strength means a cyclic load is applied on the material. Just best example is internal combustion engine. You already know that in the internal combustion engine or IC engine, what happens in every cycle? There is a combustion. It produces a power. So that power will exert the stress. Okay. In cyclic, it will produces a load. Okay. In that situation, it should sustain very high fatigue strength. A good bearing material should absorb the fatigue strength or should absorb the fatigue load and also having a very high fatigue strength. Clear? So these are all strength with respect to the load carrying capacity. I am talking about load carrying capacity. If the bearing is operating under very high load carrying capacity, if the bearing is operating under very high load carrying capacity, in that situation we have to follow these allowable compressive strength, then strength, fatigue strength, and also holding strength of the material. Clear? So these are all contributing to the load carrying capacity of the bearing material. If you're not concentrating on load carrying capacity, okay, you don't worry about the allowable strength. Don't worry about the fatigue strength. If the bearing operating under high load carrying capacity, then we have to concentrate on these strength. Clear? These are the primary parameters which we have to take care for load carrying capacity. So next property. So load carrying capacity is a one property. Okay. So the next property is compactability. So compactability means the shaft and the bearing materials. Means shaft means journal. Okay. The journal and the bearing material is rubbing conditions should not produce localized weld leading to scoring or seizing. Okay. So means if the two surfaces, journal surface and the bearing surface is come into contact, it may leads to the heat. That heat may friction, then it produces some sort of welds. So what is meant by welding? In the application of heat, okay, the two components are come into contact. Okay, here also same thing, because of the friction it may induce the heat, and that heat may start weld one surface over another surface. It should not happen. Okay, it should be compactable, means it should not weld one surface over another surface at a time of operating zone. We are talking about the operating zone. Operating zone means where the two surfaces are come into contact. That is called operating zone or operating area. In that situation, it should not weld two surfaces. What happens if the one surface welding over another surface? What happens? It ceases the operation. Clear? If the journal welding over another bearing surface, what happens? It stops the rotation. Correct? The shaft means it should always rotate. If it is welding over another surface, what happens? It will stop the motion. Motion means it will cease the operation. Clear? That's should have very high compactability. the bearing material should have high compactability. That we can expect in a good bearing shaft metal combination is necessary. Okay, so yelli antandre a bearing and shaft metal combination means both are should be metal. Then we can expect a good compactability in the bearing material. Clear? The next property is a bearing material should have high compactability. So next property is corrosion resistance. Means the bearing material should have corrosion resistant property. What happens if not? What happens if it is not a corrosion resistance? Then it will produces a layer. It may contact with the moisture or atmosphere, and oxidation may takes place and produces a layer called rust. That rust is a type of wear. Correct? It may damage the shaft surface. Okay? It should have a high corrosion resistance property. The bearing material should have high corrosion resistance property. So next property, that high corrosion resistance property is can enhance by, it may enhance by using additives or anti-corrosion resistance material. Either may directly use anti-corrosion resistance material or may increase by using some of the additives in the material, so that we can increase the corrosion resistance property. So after that, next property, conformability, means it helps to accommodate the misalignment. We already know that the shaft as well as journal always subjected to high loading or high speed. It may subject to high load or high speed. In that situation, what happens? There is a chances of misalignment between the shaft and the bearing, or if the viscosity of the lubricant is very low, in that case also there is a misalignment. Okay, if that misalignment may increases, it may increase the contact area, then increase the friction, then lead to the wear. So that can avoided by that bearing material should accommodate the misalignment, as well as increase the pressure bearing area. Means that bearing material should bear the pressure itself, it should absorb the pressure or bear the pressure, means reduce the localized forces. It should reduce the localized forces. So localized force andre gottalla, the force which is concentrating on one particular area, that you already studied in the mechanics of materials. So that should be avoid. If the localized forces increases, what happens? It may lead to the localized stress. If stress increases, it may lead to the strain. So strain means deformation. Clear? Again, it may increase the fracture or failure of the component. That we should decrease. Clear? And relatively soft materials, a bearing alloy are provide the better. By using a soft material, we can reduce them. And the next property is embeddability. So it is another important property of the bearing material. Okay. So it is an ability of a material to embed dirt. Dirt means contamination. So contamination in the where the foreign particles are contamination in lubricant, because journal and bearing should be operating between lubricant. That lubricant may consist of foreign particles, dirt or contamination. Clear? So to prevent scoring or wear. Scoring means that is what? Abrasion. Okay, or seizing. So that should reduced, means decrease the absorption. So you already know that adhesion, absorption, they are all a type of weights. Clear? So that we can reduce by a good embeddability between that bearing material. That bearing material should absorb or embed the foreign particles or contamination to reduce the scoring or to reduce the welding. Clear? A bearing material should have a high embeddability, means it will embed the dirt or foreign particles or contamination. Contamination means that lubricant may contain some particles, a hard particles. Okay, that hard particles may rupture the bearing or it may rupture the bearing or journal surface. Clear? So that can reduce by using a better embeddability of the material, bearing material. So that with a high hardness value. If the material having a high hardness, it produces a poor embeddability. Means if the material having a soft, means less hardness, it may increase. So next, another properties of the bearing materials. Again, a low coefficient of friction. So you already know that what is meant by low coefficient of friction. Coefficient of friction means, what is meant by coefficient of friction? Small f. Tell me the equation at least. Small f is equal to frictional force divided by operating load, W, capital F by W. Okay. So always coefficient of friction should be less or more. In general, it should be less. Okay. So this bearing material should have very low coefficient of friction. If coefficient of friction increases, indirectly it will increase the friction, because the equation is small f is equal to capital F by W. If coefficient of friction increases, indirectly it will either increase the friction or decrease the load carrying capacity, that is W. Okay, but actually coefficient of friction should be less. It increase the load carrying capacity, also decrease the frictional force. A good bearing material should have a low coefficient of friction to increase the load carrying capacity as well as to reduce the friction force. Clear? So next property is a low thermal expansion. Whether it should be high or low, the thermal expansion. So thermal expansion means, I think you studied in the mechanics of material. Thermal expansion means with change in the pressure, change in the temperature, it will change the property of the material so that may deform. By increasing temperature, it may deform in the x direction, y direction or z direction. Correct? That is a thermal expansion. Change in the temperature may change in the dimension or shape of the component. So here, for a better or preferred bearing material should have a low thermal expansion. Even though temperature increases, it should not change its expansion or dimension. Clear? If the temperature increases also, it should not change its shape. Clear? Because these two are operating, means they are rubbing, correct? Journal as well as bearing are the rubbing process. So where there is a rubbing, there is an increase in the temperature. Take an example. If you rub your hands, what happens? What happens? It generates the heat. The same concept in the journal and the bearing surfaces. If they are rubbed together, it will increase the temperature. Once the temperature increases, if it is a very sensitive to the thermal expansion, then what happens? Even small increase in the temperature, it may change the dimension. Once the dimension changes, what happens? Again, friction increases because the contact area increases. The contact area increases, friction increases, again temperature increases, and finally lead to the wear or failure. Clear? That's why you should have very low thermal expansion. But next property is it should have high thermal conductivity. So what is the thermal conductivity? Yes, heat absorbing capacity. Okay, heat absorbing capacity of the material is called thermal conductivity. So here bearing material should absorb the heat and should transfer heat from one point to another point, means operating zone to another. Clear? So here we have to reduce the temperature, correct? To reduce the temperature, either we can use the lubricant. Of course, lubricant will carry the some amount of the heat. Along with the flow, it will carry the heat, correct? But here, a better bearing material should absorb the heat, should conduct the heat, or should transfer heat from one point operating zone to another, so that it will reduce the friction. Clear? That's why high thermal conductivity. The material should have high thermal conductivity just to carry the heat from operating zone to outside. Clear? But a thermal expansion should be less, but thermal conductivity should be more. Clear? So next, wettability. It means, wettability means the adhesion between the lubricant and the bearing material. So we already know that in our Newton's law of viscosity, or in the Huygens Poiseuille law, in the assumptions, we already know that there is a perfect adhesion. There is a perfect adhesion between the bearing surface as well as the lubricant surface. If there is a perfect adhesion, that is what wettability. What happens? Whatever the velocity having a surface, the same velocity on the lubricant. Clear? Because of that velocity, it may increase the pressure. If the pressure increases, load carrying capacity of the journal also increases. So that it should have a perfect adhesion between the lubricant and the bearing material. Lubricant and the journal surface. There are two types of surface. One is bearing surface and other one is journal surface. Always journal surface is moving one, bearing surface is stationary one. It is not moving. Is it correct? Bearing surface called stationary surface, journal surface called moving surface. So there is a perfect adhesion between journal, lubricant and the bearing. Clear? That's why it should have very high wettability. And next is relatively hardness. Hardness means here either the bearing material should be hard, high hardness, or low hardness. If it is a low hardness, it is a soft material. If it is a high hardness, it is a hard material. Okay. So again, that hardness directly contributing to the load carrying capacity. Okay, as well as embeddability. Okay. If it is a soft material, it is having a very high embeddability. If it is a hard material, it directly contributing to the strength, it increases the load carrying capacity. Hardness means we already know that. What is meant by hardness? Hardness is a property of a material which is resistance against to the scratches or indentations. Okay. So here, if the two surfaces are operating, okay, that lubricant may having some sort of contaminations or dirt particles. Because of the load, what happens, that foreign particles may rub against to the surfaces. If it is a soft material, it may easily scratches. Okay, hardness is less means it easily scratches on the surfaces. That scratches may lead to the wear or may lead to the failure of the component. Okay, so it should have a proper hardness, and that hardness is directly depends on the whether which type of applications we are going with a high load applications or we are going with a low load applications. Based on that, we are going to select the relative hardness. Okay. So next properties are elasticity, availability and cost. So elasticity means we already know that by application of load, the material will deform, and by removing load, it will regain its all original size and shape. It is called elastic material. Okay. So here also that our bearing material should be elastic material. By the application it may deform. By removing load it should regain its all original size and shape. Okay, it should be elastic material. Next is availability, means our bearing material should be easily available. It should be easily available. Clear? Availability. If it is not easily available, what happens indirectly? It increases the cost. Okay, and the last property is cost. It should be economical. The bearing material should be highly economical. Means if it is a low cost, we can easily use. If it is a high cost, then entire process will become a very high. Maintenance cost again and operating cost is again. Okay, it may become a very costly. So that the cost of the bearing material should be nominal or economical. Then only we can use. Example, gold. Gold is a very high cost. We cannot use as a bearing material. Clear? Like this. And these bearing materials again we use depends on the type of the operating conditions. We cannot expect all these bearing materials, bearing properties in one single material. Clear? Just a minute.